Hey, good afternoon, everybody. I'm Drew Farris. This is Hannah Payon, and we're going to be talking about Datawave today. So before I get into the agenda, I just want to acknowledge the fact that Datawave is a product of many years of hard work from lots of individuals, and we're just having the honor of talking about it today. So just wanted to acknowledge the fact that everybody, some of you who are folks in this room that have put your blood, sweat, and tears into making Datawave what it is today. Thanks for all you've done. So we're going to start off talking with some essential background knowledge that we assume going into working with Datawave and the talk that we have here today. We'll talk over some expectations, what Datawave is and what it isn't. We'll go through the high-level architecture, talk you through some key concepts, and how to get started with the Datawave Quickstart. And then we'll get into the nitty-gritty, some of the ingest and query and table structures that are important to know about. And once you've gone through the Datawave Quickstart, what to try next to continue your journey on Datawave education. As you dive into Datawave, you kind of need to have an experience or understanding of what Hadoop is all about. Specifically, HDFS is really important when building your Datawave understanding, but it's worth knowing about Yarn and MapReduce. A significant portion of Ingest is implemented as MapReduce jobs. Familiarity with Accumulo is important as well. Accumulo provides the backing store that Datawave uses to store all its data. So being familiar with the general architecture, the iterator framework, how authorizations work, and then having facility with the Datawave shell is important for inspecting what's going on under the Accumulo shell is important for inspecting what's going on under the hood. Zookeeper, it's worth being familiar with in terms of maybe setting it up or understanding its basic fundamental operations, but knowing the API or the low-level details of Zookeeper really probably isn't that important. And then the web tier component of Datawave is deployed on Wildfly, which some of you may be familiar with knowing it as the JBoss application service. A lot of Datawave's front end is implemented as EJBs in one form or another using container dependency injection. So being familiar with Wildfly is useful when setting up and running and exploring Datawave. So we'll get started with the foundations, right? Because for those of you who don't know what Datawave is, we really haven't told you what it's all about yet.
Thank you, Drew. So Datawave is a storage and retrieval engine that is built on top of Accumulo, taking advantage of some of its features like cell-level security, age-off, and the dynamic ability to add splits and rebalance data for better parallelization. Datawave provides a tunable ingest workflow to get data into Accumulo, indexed, normalized, and ready for query using Datawave's Query API. Datawave will take queries and perform some parsing, validation, and construct a plan for that query for optimized execution. You're not roped into any one particular data format to use Datawave. It was configured to support multiple data types.
So based on that, you may be thinking that it sounds a lot like things you've worked with before in one way or another. But it's important to realize that there are some things that are just not present that Datawave doesn't necessarily support. It's not a relational database, right? It's not something that you can write SQL queries against to pull data out of. It doesn't really have a notion of tables per se. It's primarily sort of a full text index. But unlike a search engine, it doesn't really implement a relevancy model where you're getting ranked results back for your full text searches because the use cases we've needed to support with Datawave really are around facilitating full retrieval of information that people are querying. And as much as Accumulo can be sometimes compared to like NoSQL databases, I think one of the key functions that you would expect from a NoSQL database, just a generic kind of put and get API for data, like S3 or some other sort of blob store like MongoDB. It's not something that Datawave supports directly, although you can kind of make it act that way. And the real reason behind any of these things, there's no real reason why Datawave can't do any of these things. It's really just not something that we needed to develop as a part of the use cases we were required to support with Datawave. So if somebody wants to add a SQL database layer to Datawave, that might be something left to the audience, right? So.
Right, so at an ultra high level, Datawave provides a way of getting data into Accumulo and out of it through Query. Out of the box, Datawave supports CSV, JSON, and HTML in the form of a Wikipedia sample. And it's very flexible in that essentially if you can write something to parse a data type into a field and value paradigm, you can ingest it and query it using Datawave. Diving slightly deeper into Datawave's architecture, typically you will have a data flow or data routing service like Apache NiFi drop data off into HDFS. HDFS is monitored by the Datawave flag maker, which is responsible for constructing a set of instructions for the ingest MapReduce job, including the command to run the job, any additional arguments, and the list of files to be processed. You have the choice of two different workflows, a low latency live feed and a high throughput bulk feed. The live feed streams data directly into Accumulo, whereas the bulk feed bulk imports them using the Datawave bulk loader. Over on the query side, we have HA Proxy as the soft load balancer. The Datawave web services are backed by Wildfly as the application service, as Drew mentioned. Queries hit the REST API, then they are parsed, validated, and a plan is constructed for those queries. The expensive evaluation portion of the query is pushed down to the Datawave iterator level, so it functions close to the data as possible. In this particular paradigm, depending on the amount of data you intend to ingest, you can run this entire architecture in one standalone instance on one node, as you'll see with the Quickstart. You could have separate HDFS clusters for the ingest side and warehouse side, or even federated warehouse instances. Taking a slightly closer look into Datawave Query, queries are essentially extended Boolean searches with some additional optional operators for further filtering your data. Syntax that is supported out of the box are Jexel and Lucene. There are some examples on the lower left-hand side if you haven't seen those before. One really cool thing about Datawave is that the query execution is shaped by data's characteristics. It takes into account things like, are your fields that you're looking for indexed, what's their cardinality, etc. As I mentioned, we use iterators to perform those low-level functions, so the heavy lifting and the more expensive execution is happening on the data as close to where it lives as possible. There are multiple REST endpoints you can use to query Datawave, but the typical workflow is as follows. You'll post to the query create endpoint, and if you've supplied it with a valid query and valid parameters, you'll get back a query ID, which you can then use as a handle to call next and start retrieving pages of results. You can call next until you receive no results, get a 204, or if you're satisfied with the number of results you have received, you can then go ahead and call close, which will free up the resources being consumed by the query. Very important to call close.
So now we've given you an overview of the architecture and some of the basic interaction of the query API. We'll talk about some of the conceptual models about how we structure data underneath the hood. The fundamental unit of data that we're storing in Datawave can be referred to as a record. You may find other words used to describe this throughout the code. Raw record container is the name of the class that you're looking for. In some cases, you may be seeing these things referred to as events or documents, but they're effectively a collection of fields and a little bit of content associated with the data. So when I talk about fields, I'm thinking about key value pairs mostly, a field name and a field value or multiple field values. And when I talk about content, you might think of that as like the content of a document, sort of like the full text or something like that. And Datawave can support content that comes in various shapes and sizes, right? So as far as fields are concerned, one record's going to have multiple fields, as I alluded to already. Fields can be multi-valued, where you have a field that's given a single name that has multiple values associated with it. And the constraint is that all the values must be the same general value type, right? They can be indexed for query or simply stored for display. And then there's special types of fields, index-only fields or fields that get tokenized. For instance, if you have a long string of text that's associated with the field value, you can break it up into individual words. So each of those words can be retrieved individually from the search API. Then there's also a notion of virtual fields where you have a field that has a certain number of names and things like that, right? So, and you can get a little bit more complex with fields as well. For instance, one of the things that we run into from time to time is the fact that if a field has multiple values, it's lexically ordered when it's stored to Accumulo. which makes things difficult in terms of having parallel fields where value A from field 1 corresponds to value A from field 2, right? So there's different field naming conventions you can use for sort of grouping data and supporting records with nested fields inside them, or nested groups of fields. So in addition to individual field types, you have a notion of this need to normalize your data as well, right? So as you all probably know, Accumulo stores things lexically sorted, and this doesn't make sense when your field value is numeric, an IP address or a geospatial coordinates or something along those lines. You have to use a normalizer to basically take that field and transform it into something that's lexically sorted. And Datawave provides a number of different normalizers out of the box to do this, and these are all tied back into the field type mechanism, right? And fields are stored in both normalized and non-normalized form in Accumulo itself. When we are building an index that's going to be scanned or searched, they get normalized and inserted to the index in normalized form. And then in the raw record storage itself, you actually see the raw original field format. So this sort of block diagram notionally represents the way we store data within Datawave. There's a number of different tables in Accumulo that support the basic Datawave indexing scheme. You have a metadata table, an edge table, a global index table, and then a shard table that is broken conceptually into a number of shards. And each of the shards has these sort of subtables organized into column families, column groups underneath. So I can get into the detail of what all those are, the role all of those play. But data generally in Datawave is partitioned into shards, and you have a number of different indexing structures that support getting that data out of those shards, right? Each shard on its own is contained within a single tablet. Each shard has its own field and term index built into it, and data and record storage. And these shards are inherently date-based, right? So one of the things you need to think about when setting up Datawave for the first time is basically how many shards you're going to have per day based on the volume of data that you're dealing with. And then it also sort of implies that a lot of the queries that are run against Datawave require begin and end dates to isolate the range in which you're scanning, even though there's other alternatives there as well as I get into the edge table. Right. So just diving a little bit deeper into the purpose of the metadata indexes within the shard table. The Datawave metadata table is a relatively small table compared to the rest of your data because that tracks basically the names of your shard, the names of your fields, the types of your fields, the normalizers that are used to structure those fields when they're being inserted into the index, and then also sort of like the last seen date, the dates that those fields were observed in the data. Just make sure that you understand that the Datawave metadata table is something entirely distinct from the Accumulo metadata table, which tracks locations of tablets and things like that on tablet servers. Datawave table, very often folks tend to call it the metadata table, and it can get a little bit confusing, so it's worth making that distinction. Finally, you have a global index table, which basically is the list of all of the values that are stored and which fields they're stored in Datawave, pointing to the shards that they appear in, right? So if I'm going to search for the word sort of Nutella, it's going to tell me which shards contain the word Nutella, right? So very often when queries are being executed, we'll hit the global index first. That'll tell us what shards we need to dive into, but it'll also help us from a query planning perspective. So for instance, if we find that term appears in a large number of shards or appears very frequently, has high cardinality, and there's other terms in the query that we can pivot off of to sort of narrow down the search space first. We'll use those terms and then push the evaluation of those other terms down into the iterator stack when we're looking at things in the shard table itself. As I said, so each global index, just to recap, points to individual shards. There's a field index within the shard table that also has the term field to document pointer as well. So once again, as we resolve queries, we go to the global index first, very often in the field index. In some cases, we also need to know term positions. So if, for instance, I'm searching for the term Nutella toast, I want to see those terms next to each other. The term index that's also part of the shard tracks term positions within a document, right? So it's a great way, given a document, also to get the list of terms that appear in that document. Okay, so aside from all of the indexes, we also have to store the records sort of in their forward form, right? So the shard record or event storage, basically for every document, it has the adjacent set, adjacently in one location in the table, it's storing all the fields for that document. The data storage stores the content associated with the object in its original form in a single row, single key value pair in Datawave. So you can easily look up that content given the ID of the object that you're looking to retrieve. And then the edge table is distinct from the shard table in that it provides a completely different set of storage, different set of tablets that the edges are stored on. And this allows you to basically take all of the fields that have the same value across multiple documents and index them adjacently to each other. So it's really easy to generate summaries for data that you are interested in finding, but it also allows you to sort of generate relationships between two different pieces of data from a single object and have them all fall together. And we'll talk a little bit about how that can be used when we get into the analytics portion later in this talk.
All right, so now that you have an idea of the tables that can be queried and a little bit of their structure, we can talk about some query abstractions and what is a syntax versus a logic. A syntax is essentially how you describe your query to Datawave in either Lucene or Jexel, like we mentioned before. We talked about, give me back all of the stuff that contains Nutella, but exactly what that stuff is, what tables are searched, how the plan is constructed, and the results that you get back are determined by the query logic that you choose. The most common query logic is the event query, which will just give you back all of the records, all fields and values for those records that match your query. The lookup UUID query is a souped up, ultra-optimized event query that will return records given a record ID. This is assuming, of course, that your data has some kind of unique identifier associated with each record that you ingest. The edge query, as you might guess, looks over the edge table to find some edges given the members and attributes that you supply in your query. And then maybe you don't necessarily want to see all the nitty-gritty details of the records that you're searching over. Maybe you want to do something more of like an existence check or get some counts, and for that you can use a discovery query logic. Then the metrics query is pretty useful. This we didn't mention the queries, the query tables before, but Datawave will keep track of what queries are executed on your system, who ran it, what the plan was, and how long it took. So it gives you an idea of how your system is being used and how well it's performing. Datawave supports analytics in a number of ways. One way is to implement an analytic as a query logic. You could have composite query logics that search across multiple tables and aggregate the results across them, or multi-step queries like the edge event query. You could also have iterative queries that take the results of the previous query and use those to construct follow-on queries, as many iterations as you need. A fun example of this could be to go set up Datawave, download the IMDb dataset, and implement a 6 degrees of Kevin Bacon query logic using Datawave edges. Another way that Datawave supports analytics is through the MapReduce jobs. You have a bulk results or MapReduce API, which supports custom one-off jobs or OOSI workflows for maybe some longer running analytics over the data. And another fun challenge, should you choose to accept it, would be to go and implement this kind of workflow using Apache Spark Runner.
All right, so now that we've given you the basics, what's the easiest way to get started? As you can imagine, and maybe as some of you have had experience, it's sort of not trivial to set up an Accumulo cluster and get off the ground running. Well, thanks to some work from Keith Ratcliffe, we have the Datawave Quickstart, which is a series of shell scripts that are designed to download all the dependencies to a local environment and do a single node installation of Datawave. And I've used VirtualBox as an excellent way to do this. The Quickstart is included with the Datawave release, and there's a series of step-by-step instructions that make it really easy to get up and running with it. It will download and install everything you need, everything from Java to Maven to Hadoop, Zookeeper, Accumulo, Wildfire, you name it. I've had a lot of success as a result, working with a clean CentOS 7 instance or something along those lines. Without, in a virtual machine as a result, because it just does everything from soup to nuts. And when you're done, you've got a Datawave Ingest and Datawave Web components up and running on top of Accumulo and all these other things. And it provides a number of test queries and it provides a test framework that includes a number of sample queries. And this is really great because it gives you a working example of the query syntax. The test framework and the queries that are provided test a number of different aspects of Datawave functionality, not just a bunch of different query logics, but a number of different query operators and things like that. So that's very useful to sort of get your head around what can be done with Datawave. And then provides a set of test SSL certs. Well, we're not going to go deep in Datawave authentication here, how it works, but it's essentially tied to client certs, using full PKI support. So you'll need to have these test certs either loaded in your browser or loaded up in the client that you're calling Datawave from. And knowing what those are opens up the door to setting up your own certs. In addition to the Quickstart, there's an extensive sort of guided tour of ingesting query that's up on the Datawave website. So getting that Quickstart running will allow you to navigate through that as well. And I was really happy to find a pretty extensive troubleshooting guide too that's been put together. So things like how do I, set up my VM so that I can automatically SSH into it is covered. So you don't need to necessarily know all the Linux foo when getting started. And it's a good way of understanding how things all fit together, right? The Quickstart is really a general purpose framework that could be used for managing services, right? So understanding how the dependencies are expressed among the various components that make up Datawave Ingest and Datawave Web, the Datawave Query, is really important. And the Quickstart conveys this without actually having to dive through documentation. The entry point is the env.sh, and that registers all the shell functions that you'll use for starting and stopping services. And as you get around, as you pull that down and start navigating around it, just remember that tab complete is your friend, and also git grep is awesome for finding out where things are defined in the various modules in Datawave. So Hannah's going to pick it up with the ingesting custom data into Datawave.
Right. So after you've got Datawave up and running and maybe CSV, JSON, etc. don't float your boat, you can do a few things to configure your own custom data type into Datawave. First and foremost, you'll need to create this config.xml file, which essentially tells Datawave how to handle your data. Sorry, I inhaled some water. So what fields to index or reverse index and how to handle them, what normalizers to use, so on and so forth. Then you'll need to decide whether you want your data type to go into the live flow or the bulk flow and configure it accordingly. In your profile under the properties directory, there are some arguments to do that. In this particular example, I've added my new type to the live ingest data types. You'll then need to add the configurations for your data type to the corresponding flagmaker.xml file. And here's one way that you can start tuning ingest. You can supply the configurations and the flag maker with some additional MapReduce arguments, things like memory, so on. And also you can configure the maximum number of files for each MapReduce job to process. For live jobs, this number tends to be kind of small, relatively speaking. And then for bulk jobs, it tends to be rather large. Definitely takes some time to look and see what classes are available so you don't reinvent the wheel, because you might find that there are some classes ingest side that meet your needs exactly or that you could simply extend. So definitely follow through some of the examples that we have, CSV, JSON, and so on. But regardless of whether you use something that is provided or whether you decide to write something yourself, you'll still need to configure an input format and record reader to take those raw records out of HDFS and pass them as key value pairs into the mapper for the MapReduce job. You'll need an ingest helper that takes those raw records and extracts those field names and values into a multi-map. And then you'll need a data type handler to use those fields and values to create accumulo entries. Some key data type handlers to take a look at are the sharded data type handler, which is responsible for performing the indexing and create entries for the shard and global index tables. There's also the content indexing column-based handler that you can use if you have some fields that need to be tokenized.
So this only really scratches the surface. As you can probably tell, there's a lot of information to be picked up around Datawave, and our real goal for today was to provide you with reference information that will allow you to find out more. Refer back to this video when it's up on the conference website. Read the code. I mean, that's the number one piece of advice for anybody who is getting started with any open source project, much less Datawave, is just read the code. Don't be afraid to read source code and understand what's going on under the hood. That's really an important skill generally to pick up, but it's important here as well, I think. And as I said, this really only scratches the surface in terms of what Datawave can do. Like, we didn't even talk about the authorization model at all in terms of how it passes authorizations down to Accumulo. The fact that you can basically ingest your data in such a way so that individual fields can be revealed to certain users or not, depending on your configuration. There's a very nice cached results API that allows you to run a large query and then manipulate those results in various ways afterwards, such as sorting and things like that, grouping. There's an extensive administration API, metrics and age off. Query metrics is really, really important as you tune your system to make sure that you understand that your users' queries are performing adequately and understanding what types of queries users are asking of the system. And age off is another interesting feature that met one of our use case requirements in terms of being only able to retain data for a certain amount of time and then being able to have Accumulo transparently age it off based on a set of configured rules, right? Something else to keep an eye out for that's coming soon is Muchos. If you were here for Mike's talk last session, he talked about how the Fluo folks developed something called Muchos to make it easier to deploy Fluo to large clusters. And I think there's some code that we're getting ready to release probably around that for Datawave as well. So it can be found at code.nsa.gov Datawave, and that'll have links to the GitHub project over at National Security Agency's GitHub organization. There's no mailing list as per se set up at this point in time, but so the issue tracker is probably the best way to ask questions about it for the time being. And pull requests are welcome. We're always looking to collaborate with folks, so feel free. Any other questions? Any questions about it at this point in time?
You looked at running Datawave.
There's some early work going on with Datawave in 2.0, I believe. I mean, at the same time, it's sort of looking at Hadoop 3 at the same time is something else we'll need to roll in. So yeah, that's early days, but I don't think there's a branch up. There is a branch up. That's right. There is a branch up now on the repository for that sort of integration work. So. Yeah. So the results, the order in which the results come back is actually non-deterministic due to the parallel nature of the way we're retrieving results from the underlying tablet servers. So that said, if you do need results in a particular sort order or something like that, that's what the cache results API is for. So. Sure. So if I understood the question correctly, is there documentation on sort of design patterns for Datawave and how somebody setting something up from scratch might start? I'd say there's nascent documentation, but I wouldn't say that it's super detailed at this point in time. I mean, one of the things that Datawave is trying to solve for people is the problem of thinking about how they have to write their data to Accumulo keys, right? Like, Datawave essentially is opinionated about how it stores its data. So I think that the sort of data structures that we support meet a fair number of use cases. The edge table, for instance, is designed to be sufficiently generic to apply to a bunch of different cases. And the Shards structure has worked great for sort of both large scale, like wildcard based retrieval, and then point lookups as well, so the individual data things. I'd say for folks needing to get started with design, probably the best way is to look at examples that are present already and see how well they can shape their data to fit those sorts of examples, if that makes sense, or how different aspects of data are handled in those examples, right? So like the sort of grouping of fields was one example that I might cite for that. So. Virtual fields and stuff like that. Yeah, so one of the things I didn't also mention is this notion of models. So virtual fields are a great way to have a field that is named multiple ways at ingest time, but there's also the case where you might want to change the names of fields at query time, right? So, or you might want to have something named different ways. So we support this notion of a query model that will allow your customers to refer to field A as something completely different. And then when they run the query, they match against field A, and the results they see are named using the names that they expect instead of that. So that's another important thing, especially if you're migrating from an older system to a newer system. You might be able to support different names for fields and things like that. So, but thanks for the question, because that helps us understand some of the gaps of where we might need to beef up the documentation for Datawave as well. So. Yeah, that's a really good point. That this notion of I have my data, what sort of like conceptual engineering do I have to do on that data to really get it to the point where I'm ready to ingest it? Yeah, that's definitely a gap in this presentation for sure. Yeah, thank you. Any other questions? All right. Well, thanks everybody. Looking forward to. Give it a try, enjoy, get your hands dirty, and ask any questions on the mailing list.